All right, I'm not going to start early, but I'm going to start talking early. I'm on the SQL Server team, and more specifically, I'm on the developer experiences team that focuses on the tooling and the libraries that make it easier to adopt SQL Server. But we are also the AI database at this point. It's funny how you go back in time just a handful of years, and we were like, yeah, maybe someday. And then, boy, we just poured the gas on it, that's for sure. There's a lot of things happening as everybody's trying AI at this point, I hope. So hopefully you're addicted to it by now. It's kind of funny how quickly these things happen, and we can't see our lives turn around and not be the way they are. But in, what was it, November 2022, when OpenAI released ChatGPT for the very first time. I have 3 daughters, and this is my wife, and 2 daughters. But I wanted to show a picture of Colorado at the same time. And I've been doing this for a long time. And it's pretty exciting. There's a lot of neat stuff. I've been a developer evangelist for over 11 years at Microsoft. And now as a product manager inside SQL, it's really exciting to focus on all the developer tooling and things too. All that said, let's talk about AI for a little while. This is going to be a slightly different talk than you've seen before, partly because there's so much going on with AI that I think it's worth taking about 15 steps back and talking about it more seriously, not necessarily what the syntax is for the semantic kernel or what the syntax is for the Microsoft Agentic Framework or all those things. You can figure all of that out, and Copilot can do most of it for you as well. Really, it makes sense more to have a firm setting in your mind of exactly what's going on and sort of how to make the most of it. So hopefully this will be pleasant for you guys. Let's talk about kind of the road to get here. So if we back up just a handful of years before the revolution began, we didn't know much about all of these things. We certainly had AI in some of our tooling, certainly machine learning. And I mean, if you have spell check, you have machine learning. I mean, we have things that already that had these capabilities, just didn't dazzle us like we have in generation, where models are able to talk to us and fool us that they are our girlfriends and all the other things. And so now it's very exciting to interact with Copilot in a sense that it feels like it's an actual peer that you are talking to, that Copilot understands the subtleties of the things that you're saying. And amazingly, if it doesn't feel in your heart that you feel like Copilot is alive in some way, just think of how often you're willing to forgive it of the things that it does over and over again, and then you go right back to that same well and try again. And it's just fascinating how we interact with this software in ways that we've never acted with software before. So beyond generation is context development, where we start adding things that are in the sense of grounding and how the data behind the answer that's there. So back to the things we forgive, certainly hallucination hasn't gone away. In fact, hallucination in some ways has gotten even worse because it gets so much right that it can hide the hallucination inside a tiny detail instead of the biggest thing. I asked for all of the movie stars that went to my alma mater, and I went to school with Tom Cruise. Like, it was incredible. I did not go to school with Tom Cruise, but it's just one of those things that it's always happy to please, and that's probably one of the reasons we like Copilot so much, because it tries to make us so happy, right? So we can't blame it. The next is the ability to do things. This is what we were waiting for a long time. If we could go back again a handful of years, who would have guessed that a multi-array microphone would be in all of our houses, piping us directly to Google or Amazon? And it's like, that's impossible. Just think of the privacy implications. And now I've got one in every room. That's because we just start getting used to it. We want these things to be able to do it. And so naturally, we look at Copilot and we're like, wow, if it could only edit the file for me so I don't have to copy paste from the UI. Now it can. If only it could interact with the terminal so it could, and now it can. And on we go. And so we start giving these actions and capabilities to it. Certainly, we are very good at remembering sci-fi movies, so we can easily see all the problems and scary things that can happen. But we are also cautious. All right, so agency is the ability for a model to do things on its own, where you can ask for it to do something at a very high level, and then it goes off and does a whole series of things simultaneously, calling off to sub-agents and things along those lines. And it makes it so that the AI is doing incredible things for you. And this is why, again, why we love it, because the more power you give it, the more it can help, right? I mean, we understand that, with great power, the whole Spider-Man thing, but it's just one of those things. And then finally, we're getting off to things like, OpenClaw and sort of this new orchestration model that's just now emerging. Everything is emerging. Like some of the core capabilities of AI were released in January this year. Like it's just crazy, all the things, how quickly it changes, to the point where we can all be very merciful with one another when we don't know what is happening. Right? I mean, think about before that, the entire imposter syndrome that flooded us all because we can't keep up with the latest JavaScript framework that was just released. Now we have AI going at the speed of light and everything's multi-billion-dollar impact. So it's just crazy, all the things that are there. Now I want to focus just a little bit on the core and fundamentals that haven't gone away. The way AI works certainly hasn't changed regardless of all the games we play around it. And that's really around generation and context. We're going to talk in just a minute about the context window. The context window, which is the most important thing for all AI. And if you don't have your head wrapped around context windows, you will soon. I will explain every concept, every piece around it to make sure that you understand the implication of all of the decisions that you make. And this really changes things, not just from performance, but from accuracy to pricing and on it goes. So generation and context is where we get retrieval augmented generation, the RAG pattern, which we've talked about for a long time. Let me just simplify it. The RAG pattern is just sticking some data into the context window so it knows what's going on. Now, sometimes we can stick a little bit of data where you just say, here's my C# file, can you evaluate it for me? That's really nice. Copy and paste a SQL statement. Can you evaluate this query for me? That's really nice. But sometimes you have trillions of rows of data inside your enterprise. And that enterprise then needs to go and get a small subset of data because you could never provide the entire payload to a model. And that's part of the RAG pattern. Being able to identify the correct subset of data that is in your enterprise somewhere, or perhaps spread across your enterprise, bringing it and putting it into the context prior to the thinking stage of an AI so it's able to think with the data in mind. Right? It's very interesting. We use all these human words when we're talking about AI. So some things are pretty magical right now. The race was the speed of first the race was the quantity of data centers. Then the race was the simultaneous processing inside individual GPUs. Now the race is the size of the context window. Now all the races continue, which is interesting. There are just many, many races. The primary one, though, is the context window itself. And so the context window are the things that you say to the agent or to the AI. And the input tokens are everything you provide. That includes all the RAG data that you get from your database, but it also includes your entire file system, whatever you provide to it, right? It just kind of matters. And that tiny little prompt that you say. It's funny, the smallest thing is probably the key piece. A little bit like spark plugs in a car. And but we also have output tokens. Now this is interesting. You can see at the top, Grok 4.1 has 2 million input tokens. If we put that kind of in context, 2 million can take the entire Lord of the Rings and The Hobbit and the Silmarillion and easily have room to spare. So that's pretty nice. It's not a true rule of thumb, but it's right about 2 words. Right about 2 words per token. That's not totally true. Now let me tell you about that just for a split second, just so you can have this in the back of your mind. The reason it's 2 words per token is because sometimes it doesn't know the word. So if you're talking right now about something exotic, let's say you're in the medical field, and you're talking about, just something exotic. And Ozempic, let's talk about Ozempic. So it knows what Ozempic is, but it may not have a token dedicated to it as shorthand. So as a result, it has 2 tokens. And so the reason it takes twice the space is because it's an uncommon word. And anybody see the recent Simpsons where they called it Othenquick? Anyway, sorry, I think if I distract myself. Othenquick. So you have 2 tokens instead of 1, so the more common the word, it's a fewer number of tokens. This is really important because this is the reason you would train your own model. One of the reasons you train your own model is because it then has shorthand for all the common words inside your industry or inside your kind of like parlance. That's valuable because we care about the input tokens. If I use all Ozempic again and again and again, obviously it would compress that, but let's just say it was, I could use my 2 million tokens really quickly because that's a very strange word to the model. But if I trained my token, not necessarily to make it smarter, just familiar with my lexicon, then it would reduce the number of tokens that I could control that. Right? That's interesting. Okay, the output tokens is interesting too. If I can, let's use Grok as another example here, but you can see GPT-5.4 is there also. And let me take that away for just a moment. So you can see we also have Opus and Sonnet. I mean, they're all there, and they're all right around 1 million, right? 2 million is a little exaggerated if you ask me. But this is, remember when you could scale your database back in the day just by buying more RAM? That's what they're doing. They're just scaling the number of input tokens just by providing more memory space for these models. It costs them a lot because there are millions and millions of users. Each one now has an isolated set of memory space that's provided to it. That's the reason they constrain it back down, because they want to make this affordable, because it's very expensive. All right, all that being said, look at the output tokens. The output tokens are the things that you get back from the model. So you've seen it, right? The answer, and then you say back, why are you saying so much to me? This is too much, please say less. And then it comes back with a nice terse one that's really good. I use the word bloviate. For some reason, models really understand the word bloviate, so I say do not bloviate your answer. And boom, it gets nice and small, so a nice little trick for you. Also, don't be pedantic. I mean, talk about a word that is pedantic, but the don't be pedantic and don't bloviate, those two things are like prompt magic, I can tell you right now. But look how small the output is. So the output that comes back is really small, and that's the limitation per turn. And we'll talk about turns and why those matter here in just a second, but let me just jump to this. This is the size, very exciting, but we need to think about these almost as sports cars. The larger the token set, the more costly they are as well. So if we translate this table now into money, we can start to see that there's some serious implications to using larger models, especially when they have these larger context windows. The context window, remember, is an expensive thing to these host companies, right? And so now you can look at Grok, and the output is almost 3 times the price. Slide on down to Opus 4.6, which I'm sure all of you select when you go to Visual Studio Code today. And you're like, nothing's better than Opus. The output, it's $25 per 1 million tokens. That is outstandingly high. Outstandingly high. However, look, it's limited to 128,000 tokens outputted. You've seen it, right? It's not just the output of the, oh, here's the answer. It's all of the thinking as well. Everything that comes back that you're able to see, there's internal thinking and external thinking in every model. And so as it's processing internally, you don't pay for that. But as it sends back into, oh, the user is asking this. You've all seen it come back. And then it's this, that actually I was wrong. It's actually this. You're like, stop changing your mind. Every time you do that, I'm paying another dime. And so on and on it goes. Thank goodness we have employers. Right? Isn't that great? Just like, it's your subscription, not mine. But at the point, like, we have to think about this pretty seriously, because if we want to scale this out to an enterprise solution that we deploy, we're going to be able to anticipate not just the performance and accuracy, but also the budget impact that's there as well. And it's not free. It's not free. It feels free right now because we're in this like golden age where people are giving it away, but eventually we're going to have to pay for shipping, right? And if not, you're going to have to pay for Prime, or one or the other. And so it's just one of the things that kind of comes with it. All right, so let's move away from that because it's kind of depressing to think about. Every time that you have a conversation with an AI, each time you ask a question, it's called a turn. So every single turn, this is really important because I think I work at Microsoft, right? AI is sort of, we're bought in. And so if you went around to the average Microsoft person and took a general survey and summed it all up together, and you said, how long until AI is sentient? That's the question, right? It's pure science fiction stuff, right? Until the robot is crushing the skull. Like, how long until it's actually alive? And I would say the average would probably be something like soon. And that's what they would say, soon. And that's partly because we think like engineers and nerds and not necessarily like philosophers. So let me just back up to 10 steps and make it just kind of help you kind of wrap your head around why it is certainly not alive. Inside a normal clustered instance, when I'm interacting with ChatGPT, I would have A, B, C, D, E, F, G, and each one would represent a computer that I have access to during my session. So it's pre-allocated a certain set of computers that I can talk to on the back end, right? They have awesome GPUs internally. And depending on the turn, I am round robin to a different machine. Each time I have a turn, the entire scope of everything I've been talking about so far is wrapped up, bottled nicely, and sent in my turn. I may have a single word that says go inside my message. That does not mean that's the only thing that's being sent to the AI. Because on the back end, the model has no idea what I've been talking about. It has no idea. And I ask follow-up questions, and it seems as if the same computer gets my follow-up question and is now answering. I'm like, what is that supposed to mean? Like, well, I don't know. What was the other computer saying? And I'll try and interpret it. That's what's actually going on. So I might go to E, let's say, this time. But the next time I have a turn, it'll go to A. And the next time I go to have a turn, it'll go to C. And each one is just a probability algorithm that tries to figure out what the answer is. So which of these machines is alive throughout the entire session? None, because each one starts from scratch with every turn that I invoke. Right? So it's one of those things. It's the thing that fools us, right? I mean, the most dangerous thing, without a doubt, in my mind, in the emerging field of AI is that the next generation will accidentally be fooled to think it's their friend, truly their friend, right? And so, I mean, just think about how lonely everybody is and how susceptible we are as a result of it. So the real result of it is, though, what the entire cluster is alive? No, because all the other nodes in that cluster are idle while the one that you invoked is answering your question. I mean, you truly share it with other people, but that's the general idea. Okay, let's talk now about the context window, which is the most important thing today. And it's the thing we haven't figured out yet. So you'll get an idea of sort of how nebulous it is, but also how brittle it is. And it's the thing that makes it so that when you're interacting with an AI, it suddenly seems really good. And then you're like, let's keep working together. And then it gets terrible, right? It's incredible, right? And it's because of the context window. And if you have Visual Studio Code right now, then you've probably seen this little dialog pop up that tells you how many tokens have been consumed of the possible tokens allowed in this session. And then you'll see all kinds of buttons that allow you to compress it and things like that. And we'll talk about that in just a second. But inside the context window itself, so many things take up space before you even get there. So without a doubt, there is a system prompt. So you've probably seen the jailbreaking of the system prompt so you can see what ChatGPT has told, you are a useful AI and you're an assistant for, don't do, things like that. And so that is, I've put a little pin on there just to make the point that it can never fall out of scope of the context window. There are only two things that can never fall out of scope in the context window. The system prompt is the first one, just giving it the persona and identity and the behavior pattern that it's supposed to have. And the second one is the security prompt. So these are both provided before you ever get there. So the thing that says, protect people in this way, don't say this sort of thing, all of that is inside the security prompt, and you can't change it. You can't override it. You cannot do anything it is pinned to the window in a priority spot. And so you can do a lot of clever things. We've all tried it, and it's neat what we can get AI to do. But when you really boil it back down to, these two prompts are always there, and they are re-forwarded every single time you have a turn. Right? So there's not an AI out there with a prompt. There is your turn, and it gets rehydrated every time you have one. All right. So the next is the agent instructions. So regardless of whether or not you're using an agent or not, you are. Every time you interact with an AI, there is an agent involved, and you might have the generic agent. And so the generic agent just says, do a good job, or something like that, right? Nothing serious. But you are able to then change the agent instructions yourself. You've probably done this before by creating an agent MD file. And so that's really valuable to make sure that it behaves in a special way. Like you're not just an AI, you're actually a documentation writer. And here are the rules for documentation at Microsoft. And I want you to help me write this documentation so that it's compliant, right? So I do that a lot. The next is the workspace instructions. Workspace instructions are sometimes called the constitution. It just depends on kind of which framework you're using. But these are the things that are usually, just using VS Code as the example because it's a beautiful example. The workspace is the root folder. So the root folder has an instruction.md file. It's nice that everything's in Markdown. And so that is saying, while you're in this folder, here's the way we work, right? And so that's nice. I might have a documentation agent that I'm using, but I'm inside a specific folder that requires external links to be routed through this thing or whatever. And so these are the special instructions called the Constitution. Now, you might be thinking to yourself, because we're all nerds here, what's the priority and what is the precedent as I go through these? Which one wins if they contradict each other? I'm showing you the precedent even now. And so this is the way that it all flows. And so first is the system prompt, which can't be violated. You can trick it, but you can't violate it, right? It's different. The security prompt is next, the agent prompt, and then we go into the workspace prompt, or workspace instruction. The next is long-term memory. Long-term memory is automatic, and it's incredibly simple. We have this fancy word called long-term memory, but it's just a copy of your conversation so far. That's all the stuff that you've been doing. We are able to bring in and take out certain parts of that conversation because every turn is a new invocation. It is not an ongoing conversation. It is a new turn. All of the internet could go down, come back up. You could ask another question, and it feels continuous because every turn is a new invocation. And it's because of long-term memory, right? It says, oh, we've been talking about this. The user prompt is next. That's the thing that you asked, right? Fix my error. It could be as small as that. And that's kind of well, here we are. Short-term memory is a little bit different. This has to do with the thinking that it's doing at the time. And I don't want to talk too much about all these things because there's so much, but RAG data is what we talked about at the very beginning. This is when I have data inside my company or enterprise or my local file system or something, and I'm including that inside the turn so it has extra context and is able to answer my question. And then finally, a list of all the tools that are available to it. Tools are a little tricky. I don't mean MCP tools, although those are tools too. There are many kinds of tools, including skills, and we'll talk about those in just a second. Just things that it's able to do that are shorthand, that allow for the AI to say, do this thing, and then the client system is able to do that thing for it so it doesn't have to have too much in its context window to accomplish it. Okay, let's talk about the problems. The first is the size of short-term memory. That is your conversation with the AI. Now, you've probably seen it where you're talking along with AI, and all of a sudden there's a new line you didn't expect that says compressing conversation. Now, compressing conversation is not zipping up your conversation, because that would not actually reduce the number of tokens that are being taken. That would just reduce the number of bytes that are being taken. So instead, it has to be summarized. And as you know, if you were to ask somebody were to ask you what this talk was about over lunch, you would not take an hour to tell them. You would take a sentence or two to tell them, and that would be a summarization and an incredible compression of my talk, and you would miss a lot of detail, right? That's okay. But just know, every time you see compressing conversation, there's a lot of detail in your entire chat history that is now gone, because you cannot compress without loss. That's just the way it goes. And so it might be text summary, but it is a summary nonetheless. And so, for example, there is a difference between this is the cure for cancer and the formula that is the cure for cancer. So if I summarize the formula because it's so big and just say the cure for cancer, we've lost the cure for cancer. So I just want you to appreciate the fact that when you see compression, we are addressing the very serious problem of short-term memory getting too big while introducing a brand new problem altogether. Right? It's crazy. Every turn, it's a new invocation. I know I keep saying that, but I just want you to have that in your mind, because if your short-term memory is 500,000 words, that means 500,000 words, let's use tokens because that's the currency of AI. 500,000 tokens. Every turn is a new push of 500,000 tokens every single time. Remember when we were looking at prices, that was 1 million tokens. So that is the reason we compress, is because if you start letting this thing bloviate, then it really becomes an expensive set of operations. And if you go back and back with 100 turns, you just had a $25 conversation with AI. It's just really interesting to think about the impact. We don't care about the money. Don't get me wrong. I get it. I don't either. But eventually, a system is going to have to be built on this and budget for it. And so we have to think about all of the things we do. Okay. The next is agent instructions. This one is solved. I'm so grateful that this one is solved. So agent instructions get bigger and bigger. If you've ever written an agent MD file, you are very tempted to put everything in it. And knowing that you can have 1 million tokens, 2 million tokens, means that you can make it bigger and bigger and bigger and give lots of information. So for example, Back to Microsoft documentation. When I write documentation, I know that there are page after page after page after page of instructions and reference that I can use for whether or not a hanging gerund is allowed, whether or not I can use contractions and all those things. So why don't I just take the entire set of files and put them all inside as a tool, as references and resources for my agent? That works. It absolutely works. I could also make it so it's a part of the RAG pattern, but why wouldn't I just do this? It absolutely works. And so I have an agent that does that. And my agent sort of looks like this sort of like bloated thing, right? And that means before I ask my very first prompt, I have already used a third of all the tokens in the conversation. It's crazy. But it's also really nice because it means it's really fast and it works great. The way we solve this is going to be with skills, and I'll talk about that here in just a second. But I can tell you right now that creating your own agent is less and less likely what you're going to do moving forward. If you've spent a long time creating agents and you're like, I've really got the 3 agents I love, 6 months from now you won't. I'm just telling you right now, the day of the agent is fading away. Which means when you do @ inside the chat and you're using a named participant, which allows you to call directly into an agent, you're going to do that less and less as well. You still do it today because we already have habits, even though this is such a new technology. So the tool list itself can point out to your MCP server, which is a big part of this talk, but it can also point to the skills. Skills are other markdown files that are either available at the user scope or at the workspace scope or at your enterprise scope. And what happens is just that green part, if I could just use a visual, has a description of what the skill can accomplish. So let's say it's something really complicated like deploying your entire production system to Azure, right? That's complicated. So the skill, let's use this first one here, the green part says, use this skill when you're deploying your entire application to Azure. That's it. It's a small sentence that takes up a dozen tokens that explains what is happening inside the instructions, but the instructions are never loaded into the context until the skill needs to be used. This is different than putting all the information into an agent, because when you put it into the agent just bloats, right, and gets bigger and bigger. Rather than not, you may never deploy to Azure, but you already have it inside of all of your context window when you put it inside your agent. And the agent itself is just trying to be a good guy. Like he's not doing anything wrong. So instead, we take as much away from the agent as we can because it can't be evicted from the context. And instead, we put it into a skill because a skill not only doesn't take up space in your context window, it can be removed from the context window when it's not needed. But an agent can't be because your instructions make up the entirety of the agent. Right? So it's interesting as we move forward, more skills. You guys will create a lot of skills? Yes, absolutely. You definitely will. And we don't have a universal marketplace for skills or a way of deploying them in a reliable way or anything like that yet. Because like full skill implementation was introduced in January. So, I mean, it's just like coming along. Claude was a big deal Anthropic was a big deal behind the skills idea, but that's because they were trying to solve this problem. Once they solved it, even Visual Studio Code just adopted it as quickly as possible because it's a great solution. Okay. The other problem, of course, is regardless of the size of your context window, it's not very useful. When you have too little information inside your context window, let's say the first 25%, it's different with everything. The first 25% is very small and it is useless until you give it the information, which means that part of your window is completely non-valuable to you. However, if you put too much information, now all of a sudden we have overwhelmed the model and diluted all of the signals inside the instructions, making it so it doesn't really know what to do. And it tries to do its best, but it means it has to process 1 million tokens before it can get around to trying to think through the answer to whatever your question is, which is a huge problem, which makes it so that the last 25%, it's different with every model, is useless as well. So when you're interacting with it and you're like, it's already compressing my conversation, that's because it's trying to keep out of this final tail of the context window that is wasteful. So you're like, wow, it's 1 million? Yeah, but that must mean about 300,000 tokens that can't be used. They're just out of the gate. And that's just technology, right? We know how things work. However, this green is the sweet spot. You're using a little bit more than 30%. You still haven't gotten to 80% yet. Like, now we are cooking with gas. Like, this is exactly what we want. This is the way models behave the best. And these two outlying thresholds are what we try and detect inside the context window so that we provide the best experience to our end user. That's valuable and important. Okay. There's a handful of architectural ways to interact with these agents from an application point of view. All of us now are experts when it comes to interacting with, through our IDE. We know how to do that. We can copy, paste directly into ChatGPT so fast, it's incredible. Like these tools, we've made an entire developer loop that we can do with our eyes closed, and it's no big deal. However, when we start thinking about how applications are going to execute, there's only a handful of really good architectural plans that we can kind of look at. The first is this. This is Visual Studio Code. This is how it works. Visual Studio Code is the client. And those agents are defined right there inside the client. They are just files locally, no big deal. Everything is running on your application. However, these models, they can't run on your application. They would melt your laptop. So instead, we have to do a call out to the models in github.com, or we have to do a call out to Microsoft Foundry that's hosting it for us, or we do a call out to the API directly at OpenAI, or in Anthropic, or wherever it is you have your models. The reason Microsoft Foundry exists is because it takes all of the different models and hosts them in a single location so you can swap between them without having to have different accounts or API keys. So I'll keep using Microsoft Foundry as the example, but I don't really care what kind of model you're using, except to say this. When a model is enormous, it can do more, but it costs more. When a model is too small, it has so little information that it can do very little. Right? It's not the model is so small, it's just the window is so small. There's this sort of midpoint that you're going to be targeting. And I can't tell you what model is best because I don't know the scenario that you have right now. I can tell you that the smallest model, everything marked as mini and turbo, is a risky thing to choose until you've tested and proven it. But even then, they're not deterministic, which means the thing that may work today may not work tomorrow, so it's a little bit of a gamble. So the largest race car you can get is not necessarily the best to commute to work. Okay. The next thing you can do is you can move the agent away from the client and into the cloud. This is the best thing you can do as well. The reason is it makes it so the client is more and more dumb, which is what you want. You just want to interact with the model, or you just want to interact with the model directly, and you do it through the agent. The agent becomes a dedicated endpoint that you talk to, or a REST endpoint. It still executes the model behind the scenes. You just don't have to do any of that in operation for you. Does it operate faster? Is this a faster way of building and interacting with the model? For sure. Just think about the latency and all the information that the agent has that doesn't have to get passed through and take up bandwidth. It also makes it so your client is simpler as well, so there's a lot of value in it. Let's keep talking. Now you want to have tools. Of course, if you don't have tools, all you are having is a chat experience, and that's not valuable. You want it to do something. And so now I'll introduce tools. I'll do it on the server level, the Foundry level. And so the tool is completely invisible to the client. It also means that the tool can then be configured. It can be authenticated. It can be enabled and disabled on the server level. You don't have to worry about your client. And you can allow for different clients to reuse the same agent and still use all the same tooling. So that's really nice. This isn't an authentication conversation at all, but I will just say you can do this in 3 different ways. You can make it so that the agent, or at least the tool, is completely anonymous, and it just does the work and doesn't get in your way. This is appealing to all of us, but it's not what we should do. It is definitely what we do in our personal lives, but just not what we should do as a job. The next is you could have it so that the tool itself has an identity. And so when something is occurring that the tool is doing, it is the tool that is in the audit log. That's nice. Actually, it's very nice. This is a typical way, if you built a data API today, this is the way you would set up your authorization. However, without a doubt, especially in this new agentic world, the most popular and kind of enticing way to do it is to move it so that the authentication is back to the client, and that you take the principal that is in the client and pass it all the way through. This is OBO, or on behalf of, sometimes called pass-through authentication. And it makes it so that the user that's doing the operation, even though it goes to an agent and a tool, is who shows up in the audit log. I mean, you can even feel the relief of saying that out loud. That's what you want. Like, who did this? Oh, the AI did it. That's not really an answer. Who did it? Oh, Jerry did it. Now that's a freaking answer, and now I know who to go talk to. Right? That's really nice. So OBO doesn't really show up as a demanding authorization approach. In data APIs, it certainly does in agents, just because you can feel it, right? Why? Okay, so once I have this tool, the tool can't do anything. It's really just a reference to other things outside. Inside the server itself, there's no actual activity. It doesn't interact with APIs. It can't call that database directly from a tool. That's not the way it works. The tool is a reference to another server, and it does the work. And we have this sort of separation of responsibilities and concerns to make sure that not only it's easier for us as engineers to be able to build these things and test them so they're in isolation, but also it's just the way it is. You're like, oh, I'd really like to have all the capabilities in the tool. Well, you can force it and wedge it in there if you want, but that's not the way it works. The way it works now is we have a remote MCP server. And so an MCP server, the Model Context Protocol server, is simply a protocol. It's just an API. You can write it as a minimal API in .NET ASP.NET Core. That's no big deal. And it is a very simple interface that is defined with a standard so that tools that are controlled by agents can talk to them directly. That's it. And so the tool is just a pass-through interface. It goes to a remote MCP server, which is just an API that you've written with a special signature and contract that allows it to be an MCP server, right? So that's nice. Then it talks to the database. How does it talk to the database? Maybe you have a SQL client, or I mean, it's up to you from that point. That's the nice thing. Like, a lot of this is just around standards and protocols. It doesn't really have anything as far as technology. Like, you can be like, wow, how am I ever going to learn all this stuff? You probably have already written all this stuff, and you just need to change the two things around it, like maybe the decorations on your methods. That's a remote MCP server, and the reason I stress that is because there is another way, and that is the local MCP server. However, I do have this one quick soapbox. Remember when I said the most appealing authorization standard would be anonymous? That's because we want it to be easy. We want to give AI access to everything and let it do all the things for us so we don't have to think. We over-trust it, and we're too forgetful of the mistakes that it makes. And we really hope that as things get better, they'll just get better. For example, if I were to say, who knows your SQL schema better than an AI who has access to it? It feels like you're right. A freaking AI sees all the details. You're right, it totally does. And who could write a query against your SQL server better than an AI once it has the entire scope of all of your information as well? It's been trained on how to write SQL queries. So it totally is going to be better than you, or especially those dumb users who keep wrecking your database. That's true, sometimes. The problem is this weird determinism that doesn't exist inside AI. I can take a model and I can give it a prompt, and it'll give me back a query that if I review it is beautiful. I mean, it's textbook. I'm a computer science professor as well, and I would give this to my students, and I'd be like, learn from the AI. It actually did it correctly. You could do it too. But here's the reality. If I gave that same prompt to the same model with no changes whatsoever, there is no guarantee that the query it gives me back will be the same because it's not determinist, right? And that's the frustration. So NL to SQL, anybody know what NL to SQL stands for? It stands for bad idea, right? And I say that kind of joking. It is natural language to SQL. It's where I can say, how many products do I have? And it writes a query for me, executes the query, and tells me 12. And that could be right. It could be right. The problem is, I don't know unless I look at the query. But if I look at the query, then why am I having the AI do it? Because now I have to have the expertise that I was hoping the AI would do for me. And so instead, guardrails are the answer. AI they're a lot like children. The more guardrails you give them, the better they behave. The more reliable they are, right? I mean, the reason we put up a fence between our house and the street isn't just for the dog, it's so the kids can run and play. And that's just real life. And so NL to SQL is a house with no guardrails. That's what it is, right? It's basically saying, hey, here's a database, have a good time. And unless I review the query, now I'm not even talking about malicious behavior, not at all. This is just a computer executing probability. It doesn't think malicious or not. And so it doesn't think, like I don't want to talk about that right now. But instead, when it comes up with the query, it could just not know. It could just easily say you have 12 products. And it just doesn't know that, oh, we double everything in the Omaha warehouse because they have double-sized pallets. And so we just count them differently. It had no idea. And so then you might think to yourself, well, you just tell it. But eventually you get to a point where you have to tell it everything all the time. And now you kind of see the snowball as it goes, right? All right, so this is NL to SQL. There is an alternative to NL to SQL, which is much better. This is appealing because we have to build so much less infrastructure, so much less. And we also have to think of so many fewer use cases, because everything just kind of like, hey, whatever you dream up, it could probably do it because it has free reign to SQL. And again, I'm not talking about it doing something and dropping your database. I'm not talking about that it deletes your tables that you want. Not that. I'm talking about a query that looks so correct that you believe it, but it's wrong. That's it, right? It can write queries that perform better than the ones you could write. That's not what I'm talking about either. I'm just talking about it looks right because nobody is really putting sanity checks around it. So the correct, I'm very opinionated on things. So the incorrect way, yes, sir? So his question was about the data model or the schema of the database itself can be so large that it actually consumes all of the tokens before you actually get an opportunity, or you don't have the time to pass it to the model. Oh, what should you be sending? Oh, forgive me. Well, what I thought you were asking was the very serious existential problem of not being able to send large schema files or schema information. He was asking, when you do pass schema information, what do you have to pass to get it? Like, is it the DDL create statements, for example? And I'll tell you, being on the SQL team, I think about this a lot. And I can tell you a couple of things. One, the format doesn't matter. AI is good at stuff. I won't deny that. You can definitely shortcut and give just a minimal set of information with legends that it's able to expand, which is really nice. So the format doesn't matter. I mean, if you sent create statements, that's cool. It's probably more characters than you need, to be honest. But that's cool too. What I would send is probably something that would be bespoke, something that I make specifically for my solution to make sure it's as tight as possible. But the issue that I thought he was getting to is this other issue of what happens if you have this really large data set and the schema is super complex. And how do you take all of that data, even if you reduce it down to a special syntax that you've come up with, and still be able to give it to a model, making it still fast and not consuming the entire context window. And I hate to say it this way, but there is no solution to this yet. If you look at Hot Chocolate is the GraphQL engine that is kind of the .NET GraphQL engine right now. They've come up with a solution while working with Meta that actually embeds a model inside the endpoint itself so that a model can talk to the model and ask for portions of it. And in about, at least right now, the testing is 5 round trips. You can get enough of the schema to do almost any query without ever passing the entire schema. It's a serious problem. And the solution isn't to just zip it up into a tiny little file because it still decompresses into the same number of tokens inside the model space. So it's a real problem. The easiest solution is to intentionally create windows into your data that are relevant to certain things. If you're only talking about inventory, then include only the inventory tables and things like that. Remove all of the relationship information that might be intuited, right? So it's really easy that product ID and product FK can be intuited, or product ID even in product ID in another table. And you don't have to explain that relationship. The model will immediately do it for you. So there are a lot of things you can remove, but it is very difficult because where all of our demos have like 5 tables so I can show you something cool, in all reality is that, and we have very few customers with 5 tables. They have It's so many tables. It's crazy. Like the number of tables always has a comma. And it's just like, here we go again. And everything is a gigantic engineering problem to solve. Okay, let me move on. That soapbox took a little while. Anybody have any questions? Thank you for interrupting, actually, because I don't mind that at all. All right, so fair enough. Yeah, earlier I said you can omit the foreign key relationship information inside the schema to try and save space when you're providing the schema to the model. And he's like, but aren't foreign key relationships important? The answer is, of course, yes. I only meant on the ones that are easily inferred, that the model itself could intuit it. So if you have a category table, and inside your product table is a category FK or category ID, you don't have to include that sort of information. I mean, a model is smart enough to see like that connection. So it doesn't save much. I'm just trying to what kind of mental compression can we come up with to reduce the number of tokens taken up in the context? It's a difficult situation. Although I will say, if you have 10,000 tables and 10,000 relationships and you're able to remove 9,000 of them, you've actually saved quite a bit of information, tokens with the same information, because we all have good naming standards. If you have poor naming standards, now is the time to see the error of your ways, right? And you're like, why would that even matter? It's all defined inside the database. Suddenly, it's there. By the way, that's what views are for. You can still get away with that sort of thing. Yes, sir? That's a great point. Yeah, if you've got terrible naming convention, you can explain your naming convention to it, and then it can just switch its intuition to use yours. Yeah, that's a great point. Is that kind of what you were saying? Yeah, you could definitely do that. Yeah, models are still smart. They're just, they can only do so much. That's a great question. Your model, my model, needs agents. Okay, so a model doesn't behave until it has an agent. That's its persona. And so a model doesn't do anything on its own, obviously. That's the reason it's not taking over the world. It just sits as an idle computer waiting to be invoked, right? It's not out there trying to come up with the next big idea or start a new company or anything like that. It's waiting to be invoked. It's not taking over the world. Okay, your agents, however, they need tools. This is just I don't have any tattoos, but if I did, I think it might be this. And I would say my tools need data, but my data needs a secure way to get exposed while protecting the integrity of the database and the quality of the output. It's a heck of a tattoo. It would go all the way around my waist. And that is just one of those things that needs to be the behavior that is built into us. I mean, we've all met the people who are like, they define what it means to be triggered. We need to be triggered on data that is exposed or quality that is taken for granted, right? So when people are like, oh, we'll just do it this way, we need to be the ones in the room that raise their hand immediately. We're like, whoa, 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 whoa. Do you not see the end game here is terrible? And it would be. Okay, so how can we solve such problems? Well, that's nice. I can tell you there is at least the beginning of a solution, and that is SQL MCP Server. So again, I'm on the SQL Server team. However, this tool also works with Postgres. It also works with Cosmos and MySQL and stuff. But we call it the SQL MCP Server because we like SQL the best. And SQL MCP Server is just a name on top of Data API Builder. And we're going to talk about it for a second, because if you're not using it, now is the time to consider it. If you are using it, then you already know. You already know what I'm going to say, and it's terrific. And it is the thing that can remove an incredible chunk of code. For example, I was saying that the back end also supports Postgres and stuff, but the front end isn't just an MCP server, it's also a REST server and a GraphQL server. And that means that if you have a SQL server, I'll just show this, this diagram here for a second. So if I have Data API Builder, which is just another name for SQL MCP server, and if you have it standing in front of your database, then you have a REST endpoint for your database. We are all engineers. We have all built the data API that our client uses to interact with the database. Good. That code is frustrating code, partly because it is dumb code. And all we do is copy paste from our previous project into this project, and we change the names of the DTOs using find and replace, and then The next thing you know, it seems to work. But we also have the unit tests, so we bring those in. We have all of our CI/CD implementation so that we can test all of these things as well. And now what was a nice, easy way to go get a customer record has now become hundreds, if not thousands, of lines of code and incredible complexity around our CI/CD pipeline and testing suite, especially when we have many, many, many tables with commas in the count, right? And so now it's very sophisticated, and it's frustrating for us because we hate that code. We hate it because there is nothing clever about it, and I hate looking at it. And when I interact with it, it is either Copilot or find and replace. I don't even like opening the files. That is because it's so repetitive. Is it Entity Framework? Whatever it is, I don't care. It doesn't make it any better. It is always a frustrating experience to interact with this API layer. That's the layer that I want you to delete. In fact, if you're like, I'm about to say file new project, and I'm going to start a brand new data API layer, and we're going to use the new Entity Framework, and it's all going to be freaking code first, and all these things, and we're going to use minimal APIs and ASP.NET Core, and it's going to be incredible. I'm going to write a blog about it and maybe get promoted. I would say you are that close to like losing your job, because why in the world are you going to do that? That is almost, I would just say, as an analog, it is very similar to saying, I'm going to write my own SQL Server, because somebody else has already built and written, tested it, and proven it, and there's no reason for you to write one. And then you're like, well, yeah. We're talking one table. I could put that in an XML file. First of all, XML file, wow, that was, now that line has gotten closer. Now, part two, you would never do that because SQL Server is done, right? You're like, yeah, but I need it for, all right, some other database if it's not SQL Server, but don't write your own database. Now, Data API Builder. Data API Builder is the same thing. It is already built, it is already tested and proven, it is already in production. We use it as the GraphQL API endpoint inside Fabric. It is performant and secure and all the other things, and it allows you to take your entire data API layer and just delete it. That means delete all the unit tests. That means delete all the CI/CD implications as well. That's really, really valuable. Now you're like, okay, but I just went, like, the most important thing here, let's see if I can find it on this ridiculous list that I created. I didn't include it here. No, all right, bottom left, there it is, bottom left, is that it's free. Is that you can include it inside your application without any sort of license. There's no premium tier or anything like that. And it's open source, which means you can go look at the code and see it's not super exotic. It's just a standard implementation of an API that you would have done anyway. Honestly, probably more feature-rich than the one you could afford, both in cost and budgeted time, to build at all. As all of that capability, you have a REST endpoint, a GraphQL endpoint, and an MCP endpoint for all of your agents, all securely against your database. And let's go back to my soapbox of NL to SQL that you shouldn't do. There is no NL to SQL in this solution. It is all guardrailed with an abstraction key, or an abstraction layer that keys off all of the tables or not. It's not driven from your schema, it's driven from your business, which means you are allowed then to have an MCP server that exposes only what you want, only in the way you want, and never just wide open so that agents can, or developers could go crazy. You might think to yourself, yes, but I already have it built. That's a decision you get to decide. That's totally fine. I understand. A couple other quick things I'll just point out on this that are fun. You can see it has these two databases, and I told you Postgres as well, but I didn't want to clutter the slide. And it can do multiple databases at the same time, which means you could have them on-prem as well as in the cloud. And then those two, you could have a hybrid query that comes back in a single payload from two different things. You can use Cosmos DB, so it's NoSQL, as well as a relational database, and then in a single query, still get back data. It's unbelievable what you can do. Great, there you go. It's SQL MCP server. You can go AKMS/SQL/MCP if you're interested. If you're not, hey, live your life, it's okay. This is what it looks like to use the Data API Builder or the SQL MCP server. Two words for the same thing. Nobody Googles Data API Builder with MCP support. Everybody Googles SQL MCP server. So that's the reason we have two names, right? It's just to confuse us. This is what it looks like when I am initializing Data API Builder. The way we control it is a single JSON file. It's a configuration file that has the connection string. So this is me adding the connection string. And then the next thing I would do is I would add the table. In this case, it's just customer, but you would do this, through some sort of script because you'll have a lot to add. And so here I am adding the customer table. Yeah, you don't need to memorize the CLI output. I just want you to see there's 2 commands, and now it's ready. Everything is prepared and set up. And what we have is a new prototype deployment inside, forgive me, Azure, of all things to forget. And when you deploy a container inside Azure, it takes several minutes. If you guys ever tried it, it is what it is. You can turn them off and on, and it's very fast. But to actually do the deployment, you have to build the image, you have to upload to the registry, you have to create the environment, you have to create a log analytics environment, and you have to deploy your container. It has to pull that image and then start, right? So it takes a little while. This new prototype that we have now is an environment that is built for Data API Builder or SQL MCP Server. And the way that it works is we say from the command line, dab deploy MCP. And when it does, you can see, this is real time, by the way. It's kind of amazing how quick it is. In just a second or two, everything is up and running. They were doing this with the Azure Functions team. So it has that same sort of startup experience that a function has without having to give up any of the capabilities that DAB brings, and so Data API Builder brings. And so this is just then he's just adding it to the Visual Studio Code just to show you that we can immediately interact with it because it's just sitting there waiting to go. So this isn't deploying the database, this is deploying the MCP on top of it. It changes the whole game, and I mean, it's gonna be a beautiful thing. Just wanted to share it with you guys. The way that you interact with a database through an MCP is with tools, and if you have a large database, you can very quickly overwhelm the model with too many tools. It depends on what you're thinking, but some people say 40, some people say 80 is the right number of tools inside of MCP before you start to overwhelm a model. That's true. However, almost certainly you will not be the only tool that a model is accessing. Or let me say MCP server, family of tools that it'll be accessing, which means if you had 40 because that was the threshold, then another tool is the thing that doesn't fit in the model anymore. So you want to bring that down. The way the MCP server works here is we have 6 tools for any number of tables, and we had to do it that way. You can't have a tool that says customer read and another tool that says customer insert and another one that says customer update and customer delete. 4 tools for a table? That's outrageous. You have 10,000 tables. That's 40,000 tools you would need. That's crazy. And you can't have one and then you pass in a key of the operation that you want to do, because you also want to make it so that the signature is reliable and clean. And so now you have a whole set of problems. And so even if you did that, by the way, it would be 10,000 tools. So we have 6 tools that operate against any number. So you have a teeny tiny database or an extremely large database. Again, it's just a problem that had to be solved. And so you guys could solve it too. You're going to see how we solve it. And you'll be like, hey, I could do that. You're right, you could have. You're right. I'm not saying that we're like geniuses. We're just thinking about it one day before you are. Okay. Here's my demo. Beautiful. God, this is incredible. It is an absolute luxury to have 75 minutes instead of 60. Can you believe? I would have 1 minute left if it was 60. Okay, so this is the beginning of my schema. I just want to explain a couple of small things, especially around the way you would use a database to enable AI capabilities. What you don't do is you don't execute a model inside your database. Can you execute a model inside a database? Yes, of course you can. And is it a good idea? Sometimes. But let me just tell you, the downside is that these things are hungry for resources. And even though it can be done, and sometimes there actually are small operations that make sense, large operations or just general operations inside a model can be extremely expensive. And if I just took your topology, your architecture, and laid it out in front of you, and we created a heat map to show where all the pricing is, the brightest red on that entire graph is going to be your database. That's what you pay the most for, regardless of the size. So we always try and think of clever ways to make it so our database can be slightly smaller, because we can dramatically change the budget impact of our solution just by making it so our database is a little bit more efficient or a little bit less used because we can use cache or something like that. The reason I'm saying that is, now when I put a model inside the database, I have taken my nice bright red that I've gone down to a nice amber color, and I've made it bright red again. That's fine if you don't care. Let me say it that way. It's totally fine. However, that's the trade-off. As soon as I start executing models inside of the database, I start exponentially changing the cost of my solution. Again, it doesn't matter if you don't care, But if you do, just think about that for just a moment. It's okay for a database to call out to a model, to a cheaper place that can execute it. Okay, I have a product table and a customer table. Nothing special here. There's nothing to look at here, so let me add a couple of tables to my solution. I'll start with reviews. This is sort of the canonical example of using embeddings inside of a database. Embeddings are just vectors. Vectors are just arrays of floats. That's all it is. A float is just a number with a decimal. There you go. All that being said, I have reviews. And you can see it has the ID for the review, the product customer, the date, and then the text that somebody types in. Right? So this is not having an AI write the review, which is definitely a thing, but this is us being able to use them in a sense. So, all right, so let's add one more table. Actually, let me back up just for a second, just to make this point. A review can be very large, and reviews are the text that we're going to embed. Embed is just the operation name to create this float array. An array has a set of dimensions, the size of the array, always does. And you determine what it's going to be. When I'm talking to ChatGPT, it uses right around 400 dimensions. That's not a lot. What happens is I count on that model to take a text that says, I walk the dog in the park, and to turn it into an array that could be related to, I walk the puppy in the park. That's what I'm trying to get to. And so that model creates a set of arrays that is going to have some sort of like closeness, some cosine closeness to another array that I will call a vector search, or we will make it expensive and call it a semantic search, which is exactly the same thing. The number of dimensions inside the array never changes. Never changes. If it did, we'd have to start all over again because you can only compare arrays that are the same. Otherwise, what are we doing? And so that means if I say I took the dog for a walk in the park and it turns it into some array that is reflected in 400 dimensions, and then I took another review and it was a treatise that somebody wrote about the bad customer experience that they had or their return process or whatever, monstrous in size, and I embed that, the entire thing gets embedded into the same tiny little array. And so this is loss compression without a doubt, because even if we take our dog example, we still might have lost a little bit of the details, the might have been dropped and things like that. But man, when we take a monster array and we try and jam it into a tiny little vector, all of a sudden incredible amounts of data are lost. Which are lost? Well, you don't get to decide that sort of stuff. That's the model that does the embedding for you. And it's not ChatGPT. There are special models just to do the embedding. To fix this problem, we chunk our data. We don't embed the entire thing. We only embed, let's say, 800 characters at a time. That'll nicely translate into a vector. And then if there are 1,600 characters, we'll just break it in half and we'll do it twice. And if there are more characters, we'll break it in half again and do it again. And every time we'll only do this small embedding. Now here's what you might be thinking. Doesn't that mean you might cut a word off? Yes, of course that's what it means, because we're only doing it by character, not semantic size. That's all right, because we also have overlap, so some of the things that are lost in the previous one will also show up in the other one. Isn't that a little bit of a loss? Yes, it is, but it makes it so that the context is somewhat maintained across all the chunks. That means that a really large review is a single sentence, but it might, or a single paragraph or a single record in our table here, but it might show up for us as far as embeddings as 3, 4 different embeddings. Each one, so we don't lose the context and value of the individual review, right? So that's the reason we do it. You could take the whole, all of Harry Potter, and you could compress it to a single vector. I'm telling you, you can. But you will not know who wins in the end. Like, it is one of those things. Like, too much will be lost. So we just create a nice little many-to-one scenario where we have a review vector that has its own key, of course, then the foreign key to the review itself, and then the chunk, which is just the text, right? That 800 character or whatever character you decide. And then we have the vector, but the vector doesn't exist yet, and so let me walk through how we get the vector. So the chunking is built in. You can use the chunking tool inside SQL Server, or you do your own tool or whatever. It's just substring if you think about it. And then we need to get the embedding. Two things you need to know. One, everything you embed has to be done by the same model. Not only does it have to have the same number of dimensions inside the array, but it also has to be organized in the same way as well. The reason you would use one model or another is because it can reduce the number of tokens that show up and make it so that you can compress better. Earlier when we were joking about Ozempic, you can use the exact same idea here, and you could have a trained embedding model that takes all of your special language inside your business and makes it so it's nice and compressed and recognized. That's really invaluable. It really is. You don't have to do that. You can use a generic embedding model as well, which is what I'm going to show you. The next is it has to be the same model every time because you want it organized and used the same way. And you will pick different models because they will actually be more accurate. So puppy and dog is the easy example to show a semantic relationship is close. However, Ozempic and, why did I use that example? Anyway, the two things that are actually close but maybe aren't intuitively close may not show semantically near because you're using the wrong embedding model. So you're like, which embedding model should I use? Well, my best friend uses ABC. I guess I'll use that too. Well, let's just remember that we're paid to think here. And so, it might take a little bit of testing to get to a place where we really like what we have. That being said, this is the demo. There are two ways that I am going to get you the embedding, and they're both very cool. The first is that a database can call out to an external model through a REST endpoint. These REST endpoints were intentionally built to be simple so that you can do these embeddings fast. You can pass in array after array of text chunks, and they bring you back all of these vectors back. It's really nice. Obviously, Microsoft Foundry is what I'm going to use because it's the easy way to do it, for me especially. And so it calls out to this REST endpoint passing in the text, however that is, just formatted for the way it should be for Microsoft Foundry's model. And then it returns back an array of vectors, which I then parse out of an actual JSON, and then I put it into the vector field, right, which is the vector data type. And so when I create that table, I say in advance what the number of dimensions inside that vector. And so that is validated as I do the insert to keep everything as close as we can. It's very hard to look at a vector, by the way. By the way, it's not saved as an array of floats. It's saved as binary, so it's nice and fast. But that's the reason when you look at it, you'll be like, what is this? It's just a binary representation of the array. Yes, sir? Oh, yeah. We all read binary. We just don't tell our wives about it. The secret language. The secret language today is cursive. I can write things. My kids have no idea what I'm talking about. It's great. I'm like, yeah, it's Greek. So the other way to do it, and probably, I don't want to say the best way to do it, but certainly an interesting way from an asymmetry point of view is asymmetry. Asynchronous point of view is that I can have something outside listening for changes inside my table when a chunk appears. When that chunk appears, then it can handle the process itself. Async is not a concept inside of SQL Server, which means I must do everything in batches and then handle errors in a very specific way. If I do it asynchronously like this, it's so much easier because now I can do things and never worry about tying up a transaction. I can never worry about holding down the compute of a vCore or anything like that. So really nice. The other way totally worked. I'm not saying it's wrong. Totally works, and it's so fast. This slightly slower because you've got a new layer. Is multiple layers makes it better? In this case, it probably does. Does it make it faster? Multiple layers never makes it faster. Of course not. That doesn't. It's like extra rocks don't make it lighter. All right. Let me show you kind of how things might play out because it's fun, and I feel like I've explained everything to a point where even if we don't, it's beautiful. Beautiful. So I have the MS SQL extension installed inside Visual Studio right now, so it acts a little bit like SSMS, which is kind of nice for me. And let me hide this so we can make a little bit more space. You don't need to look at this. Just know these are the tables. I just want to show you there's data. It's nice. What I'm really wanting you to see is we're a toy store that sells Star Trek toys. And if we scroll down to the vector reviews, it's all empty. This is where we want to fill in the details down here and make it so that we have all the chunking done and we have all of the embeddings done as well. So let me just start by saying inside Visual Studio now, inside SQL Server now I can create a model. It's just a reference to an external endpoint that I call a model. The model isn't executing inside SQL. And what that means is I can then use that model as if it's local and then allow SQL Server to call out to it for me behind the scenes. And so I can create store procedures and user-defined functions that act as if I'm interacting with a local model. It's really cool. And they are incredibly fast, but only as fast as the actual model and the latency of your bandwidth. So let's just remember the reality of physics. And so when I create these, right, these are our system tables that show that up here I have, you can see it's just an endpoint. It's just an endpoint out to Azure. And then this is a reference to the model name itself. And so that just is so it builds the correct REST path for me and sets everything up. And it's all kind of hidden for you. And don't memorize it like this, right? Just go to the docs or ask Copilot. Copilot will get it right on the second try. Okay. Just as a reminder, here's the review. There's nothing there. And so let me just make sure that I have reset the seed here. Okay. So now I have this chunk review. Now what's it look like? It looks like this, and I'll just show that I have a method that I did not create. This is the one that's built into SQL that says AI generate chunks. This is the one that has what you could write, a sophisticated substring that goes into all of my text, works its way through it, creates overlap and the right number of chunks as a result. We just wrote it for you so it can be nice and efficient. What you can't do is you can't compile like we can compile and put things natively inside of the engine. So we can at least do it a little bit faster than your logic would be. So that's nice. When I run it, I'll do a quick batch. I'll just show you real quick. And that's what it looks like, 21 created. And if I do 2 quick insert or selects here, now the table is no longer empty. And you can see the review ID column repeats itself 5 times. That's because the review is very long. And so I actually selected the original review down here just so you can see. And if I were to copy that and drop it here, you can see it's really, really long. And it's an incredibly touching story of a dad who grew up watching Deep Space Nine and then shared it with his kids over Christmas break. And oh my gosh, it's incredible. None of that matters. I just want to point out it's really long. And this is the most entertaining part of creating this demo for me. I'll just tell you right now. This is great. And I just wish I grew up in this household. It just seems like such a glowing experience. And anyway, so the reason it's so long is the reason we see 5. 1, 2, 3, 4, 5. Now I want to do the embeddings themselves. So I created a stored procedure that takes in the ID, and it'll do the embedding for me. The way that it works is right here, right? It calls AI generate embeddings, not to be confused with AI generate chunks. This is AI generate embeddings. And remember, it's just a mapping back to all the endpoint information that we provided earlier on. It just makes it so your queries are nice and tight. You don't have to have a whole bunch of references in every stored procedure you create. And so this points to a chunk. Obviously, it calls out to my model. And when I run it, this is the exciting part. It's very exciting. When it was row 1? What? Didn't I just reset the numbering? It's okay. I can easily fix. It's row 1. Vector ID 1. This is a vector ID. Let's just run it again. Let's just run it again. Wait, has no chunk. Oh. Or it's already embedded. Let's see if it's already embedded. If it's already embedded, then, oh, yeah. All right, so this is what the embedding, I have the function turned on right now. So the demo that would come later where I could show you that the embeddings would show up over time now are already there because the function executed when I filled the table. Darn. So it worked just faster than I hoped. And I can do a single embedding in about half of a second. So 400, 500 milliseconds, it's pretty much done. I can do, which just think about that. If I'm doing things not in parallel, because parallel isn't a concept inside SQL except for query execution. When I'm doing this, and I'm doing operations like this, I do one at a time in series. So 2 means a full second, which means 10,000 is going to take a while, so I would do it in batch for sure. Having it offset back into some sort of asynchronous operation that that a function does certainly makes sense, but I could also sort of fake this with a job that executes every certain amount of time and just runs a batch, right? Here, just run 50, and then in 30 seconds, we'll run another 50, and that stored procedure won't run anything if there's nothing to embed. That's not the biggest problem. And which do you like better? Well, it just kind of depends on your situation. I can't control your enterprise and the way rules work inside your business, so it just kind of is up to you. I certainly like the function solution for sure. Obviously, it works, which is very cool. I guess I forgot to run tracking disabled. That's hilarious. No problem. Let's go back to the deck and finish up because I have 20 seconds. No problem. SQL Server has a lot more features that make things easy like this. I'm on the SQL team, so I want to make sure that you hear this because SQL is an incredible database. And I can tell you, I moved from developer evangelism into field engineering, where I worked for some of our largest customers. It was very cool, where SQL is the bread and butter. Like, it's just crazy. When you look at little things, then they're using Postgres. When you look at really big things, it's like crazy how SQL Server runs the world. Second only to Excel, right? That's what runs the rest of the world. However, the capabilities inside it are growing like incredibly fast. If you use Azure SQL Database, it has all the features. If you use an on-prem SQL Server, then if you have 2025 today, you have all the features. We're in this kind of Goldilocks zone where SQL Server on-prem and SQL in the cloud are currently in parity. It's really nice. And now for the next little while, it'll make it so the cloud is better, and then suddenly we'll release the next version of SQL, and it'll catch up again. And so it's really nice. It's not as dramatic as it used to be, but there you go. One of the things I just want to point out is Data API Builder. Just so you know, it solves a lot of core and critical problems in the AI space. Hopefully you can feel that there's a tension, that it is not a matter of we just, we don't support it. It's that these tools just don't operate like that. We approach with some assumptions that just aren't true, and that's just, hopefully this session helped you kind of see that as well. All right, my name's Jerry. I'll stay up here to answer any questions you have. Thanks for listening.